now that we know what a radical is and what it represents, we're going to shift gears, and in just as quickly as moving into the next section, we're going to actually learn of a new way to represent a radical. So here's your definition, and I'll talk about it. There's really not anything to understand. It's just a definition that some mathematicians at some point, scientists, decided to use, and we've been using it ever since, and it's worked really handily, and it's really helped us out a lot in a lot of different situations. So basically, when you have the radical notation on this side, so that's what that represents, right? So that's radical notation. We learn to reread that as the nth root of a. It turns out that this is the same thing as saying a to the 1 over n power, all right? And so what happened here? Well, what used to be my radicand a, right, has turned into the base. So basically the base and the radicand are essentially the same thing. So what used to be the radicand in the radical statement is the base in my exponential statement. So that's the first thing that happened. The index. Well, the index in the radical expression turns out to be in the denominator of the fractional exponent. So that's what happened to the index. And then what we're going to learn, and let me go ahead and throw it at you right now, this a right now is raised technically to the first power. And so that's what that 1 represents. So I have a to the first power, right? The nth root of a to the first power, is another way to say that now, is equal to taking that a and raising it to the 1 over n. So it's just a new way of saying the same thing. It actually helps us in certain situations, and it works like a charm. So let's spend some time actually just doing some conversions first, walking from one expression to the other, and then doing some evaluations, and we'll slowly pick things up. So in 10.1, we call this the square root of 25. And what we are now going to say is that this is 25 parentheses to the 1/2 power. So again, whatever the radicand is inside of here, right, it's being raised to the first power, and the index is 2. So the radicand, the base in here, becomes the base of the exponent. The 2 becomes the denominator, and then our power is 1. So 25 to the 1/2 power. That's another way to write that. In 10.1, we said this was the cube root of x, and in 10.2, we are saying that this is x to the 1/3 power. So again, the x turns into the base, the index becomes the denominator, and technically rid of the first power, so we get our 1 there. So x to the 1/3, and on and on and on. Be careful here, this entire 1 over 64 serves as the radicand, so when I convert to exponential expressions, I need to make sure that that is in the base. So 1 over 64 would be in parentheses, and then this would be to the 1/4 power. Again, the base and the index becomes the denominator. Of course, this is all to the first power. Again, be careful what the radical is being applied to. So in this next expression, the radical is just applying to the top. So if I had to change this, this would be 32 to the 1/5 power. And of course, that 6 isn't being impacted by the radical, so it shouldn't be impacted by the exponent as well. So you can already hear me using that exponent language back in chapter 4, where we had to really be careful about what the base is. Same thing here. So how about going the other way around? So this last round we had radicals, we converted to fractions. What happens if I already have fractions? Well, again, whatever the base is becomes the radicand. So this 100 will be sitting under the radical sign. My index is 2, so we're basically talking about the square root of 100. This y becomes the radicand to the first power if you wanted to, and this 3 tells us what the index. So y to the 1/3 is the same thing as saying the 3rd root of y. Again, careful with the fractions here, the parentheses. The entire thing, 9/16, goes underneath the radical. And what's the index? Well, it's 2 here. So we're talking about the square root of 9 over 16. So notice the whole fraction is under the radical. As opposed to D, the fractional exponents only apply to the bottom. So this would be 7. 16 is under the radical, and our index is 4. So we're talking about 7 over the 4th root of 16 in that example. So there's a really quick conversion from one to the other. Hopefully you see it's pretty easy. It's just another way of saying the same thing. And since that's the case, we can do some evaluations. So if I have 1/25 to the 1/3 power, if you don't like seeing it this way, convert it into the radical that it is. So 125 becomes the radicand. The index is going to be 3, so we're talking about the cube root of 125. And of course we know that to be 5, right? Because 5 times 5 times 5 is 125. So this is just a fancy way of saying 5. Here, I mistakenly kept it as radical. I just noticed that. The 4th root of 16, we know that to be 2, right? Because 2 times 2 times 2 times 2 is 16, and then we're over 8. Of course, all fractions should be reduced. So the radical actually goes away totally there, and we get 1/4. So don't forget to simplify your fractions. The fraction 1/49 to the 1/2 power, well, this is basically saying the square root of 100/49. And as we saw earlier, we can break this up. The square root of 100 is 10. The square root of 49 is 7. And so this becomes 10/7, or 10/7 times 10/7 equals 100/49. So we're talking square root there. All right, so perfect. The next one, again, be careful, order of operations come into play. We are multiplying here, right? But we're supposed to do exponents first before we multiply. And so this exponent, this kind of gets ready for the next section here. This is only being applied, right, to there. So this is a multiplication. So we're going to hold off to that 5, and this turns into the 5th root of 32. Of course, what is the 5th root of 32? Well, that's 2 times 2 times 2 times 2 times 2. That gives us 2. And of course, we're multiplying it to 5. So this guy would evaluate out to 10. So again, there's our new definition. We can say something radically, or we can say something with a fractional exponent. We can walk it back and forth like we did here. And of course, we can start to do evaluations using this new form. Much more ahead. I'll see you in the next video.